can submit them to the Tutor Tuesday. All right. Let's see what we got going on here. So for those of you who don't know, the Tutor Tuesday, it's basically I'm going to go over SAT, ACT, and AMC math problems. Right, so we're going to go over all of that stuff. If you have questions that you want me to cover, yeah, screen should be showing. Let me reshare if it's not working. If you have questions that you guys want me to cover, you can submit them in the chat. Let's go ahead and let's get started. Oh, need my drawing pad real quick. So yeah, we're going to go over first some SAT warm-up problems. So let's start with that. Let's see what we got here. First question we've got here. If x over 8 is equal to 5, what is the value of 8 over x? I think you guys should be able to tell me this. People in the chat right now, what do you guys think for this? I think it should be fairly simple for our first warm-up problem. What have we got? 40? 40? Yeah, 40 is not correct, unfortunately. That would be the value of x. But if you look at x over, or 8 over x, 8 over x is just a reciprocal of x over 8, right? So if x over 8 equals, let's call it 5 over 1, if we take the reciprocal, we flip it, we're going to get an equation that looks like 8 over x is equal to 1 over 5. Yeah, let me send the question as well. But yeah, for this one, the answer is 1/5. Let me copy our question into the chat for people who can't see. We've got another warm-up SAT problem. This one says, the table summarizes the distribution of color and shape for 100 tiles of equal area. If one of these tiles is selected at random, what is the probability of selecting a red tile? Express your answer as a decimal or fraction. Any ideas in the chat here? I'm going to go ahead and say one of these tiles selected at random, the probability of selecting a red tile, that's going to be the probability or the number of red tiles over the total amount of tiles, 30 over 100. That should be pretty straightforward. But if you put 30 over 100 into the answer box on the SAT, that would be wrong. You would want to simplify this to either 3/10 or 0.3. Got that one? 300 over 100. Yeah, 3 over 10 or 0.3. Alright, our third warm-up problem here. The function f is given by the function f is defined by the given equation. For what value of x does f of x reach its minimum? Minimum value, we're given this weird kind of form of the equation. You could try plugging in all of these and seeing what you get, but that wouldn't be a very useful strategy. What you could do instead is take note of the symmetry of a quadratic equation or parabola. The fact that it's symmetrical around its vertex means that the roots will be symmetrical around the vertex, and that vertex is its minimum. So I see the solutions for this one are x equals 10 and negative 13. And if we plot out negative 13 right here and 10 right here, then the vertex is going to be somewhere in the middle of those two. So let me mark that in like a light green. That's the vertex. That's also the minimum. And of course, if we take note of that symmetry, then the vertex, of course, has to be the average of those two zeros. Right? So we could just write the average of negative 13 and 10. That's going to equal to negative 3 over 2, which is exactly answer choice D. Negative 3 halves. Ooh, I forgot to send a picture of that one. Let me send a picture of that solution in chat for you guys. Alright, hopefully that one's good. And let me paste in our last question here. Number 22. Alright. If a new graph of three linear equations is created using the system of equations shown, and the equation x plus 4y equals negative 16, how many solutions x, y will the resulting systems of three equations have? Let's see, we've got one equation that looks like just y equals 2. We've got another equation that's right here, which you could probably figure out the formula, but you don't need to. Let me just dot these out to show you guys where the equations are. If we put in a third equation, x plus 4y equals negative 16, that's not really clear what that looks like, so let me convert that into y equals mx plus b form. So we could do something like 4y equals negative 16 minus x, and if we divide everything by 4, we could get y equals negative x over 4 minus 4. Right, so plotting that out on this graph right here, it's going to be a slope of negative 1/4 and an intercept of negative 4. It's going to look something like that. And in fact, that just looks like it's parallel to this first equation right here. So there's going to be no solutions to this system of three equations because they're never going to intersect at just one point. Did everyone get that right? Not sure. But we'll keep moving on. What we've got next is some harder ACT math problems. So I picked these out specifically from one of the old tests. Let me put the question in the chat for everybody. See if you can figure this out. And in the meantime, let me read the question out. So we've got each of the following graphs in the standard xy coordinate plane has the same scale on both axes. One graph is the graph of ax plus by is less than or equal to c, where 0 is less than a, is less than b, is less than c. Which one is it? Okay, take a look at those graphs. See if you guys have any intuition on this. Right away, what I'm seeing is that again it's not in like a y equals mx plus b form, so I'm gonna convert it to that. This is gonna become by is less than negative ax plus c, or y is less than or equal to negative a over b x plus c over b. So looking at the equation here, we're going to want something that has a negative slope. We can rule out f. F is not correct. We also want the y values to be less than the line, so we can rule out g and h. Between j and k, let's see. We know that C and B are both above 0. So if I divide C and B should, or C divided by B should be a positive number. So that intercept should be positive. The only one that matches with a positive intercept is answer choice K. Clear on that? Yeah, K. That seemed like a tricky one, but definitely answer choice K for this one. Alright, let's see what we've got next. Number 57, which I'll paste in the chat, don't you worry. You can try solving this one out on your own. It's a bit of a long question, but let me read it through. The art club designed and made banners of the school colors, blue and white, for their fundraiser. Each banner required 1/4 of a yard of blue material and 3/8 of a yard of white material. The club originally planned to purchase exactly enough material to make 500 banners, but found the material to be cheaper if purchased in full bolts, the blue material in 10-yard bolts, and the white material in 12-yard bolts. How many extra banners was the club able to make if they purchased enough full bolts to make at least 500 banners? Well, let's see. How many bolts would they even need to make 500 banners? To make 500 blue banners, and each one takes 1/4 of a yard of blue material, that would take us 125 yards of blue. If we wanted to make 500 banners of white, and each banner is 3/8 of a yard, that's going to be 500 times 3/8 is, that's going to be 187.5 yards of white. So they need, how many bolts, how many 10-yard bolts do they need to make blue? Well, they would need 13 bolts of blue, since that would give them 130 yards material. Remember that each one is 10 yards. And if they want to make 187.5 yards of white, they would need at least 16 bolts of the white material. And that would give us 16 times 12 is 192 yards of material, white material. So they got their 500 banners. Now they have extra material. They have how much extra material? Already here, extra. They have 5 yards of blue, right? They purchased 130, they used 125, they have 5 yards of blue material, and they have 192 minus 187.5, 4.5 yards of white. And seeing as we also use white at a faster rate than the blue, we use 3/8 of a yard, the 4.5 yards of white material is our limiting factor. So the amount of extra banners that they could make is just the 4.5 yards that they have divided by the 3/8 yard that it takes to make one banner. That would equal 4.5 divided by 3/8. It should be 12 extra. 12 extra banners. That would make our answer choice A. Everybody able to follow with that one? Oh, I see some people got the answer in the chat. Yeah. Yeah, it's going to be 12. Cool. So I guess that means we can move on to our next ACT math problem. This one looks like a fun one. It's got to do with graphing the equation. 59. The graph in the standard xy coordinate plane below is the graph of one of the following functions. Which one? Okay. Oops. Doesn't look too bad, but we do have to know about our functions and multiplicity as well. Hold on, give me a sec for my pen. While we take a look at this, we can notice some things about the graph. Like the fact that it's an even function. So that means that its end behavior goes up in both directions. And that also means that the exponents, the highest leading power must also be even. We have to have like a x squared or x to the fourth or x to the sixth, x to the eighth. We can't have something like x cubed. So we could rule out answer choice A, right? That would be x times x times x, that's x cubed. B could work, C could work, D could work, and E could work. So that didn't really rule out that much. So then we can start looking at the roots. I see a root at -4, one at 0, and one at 6. So the factors for that would look something like x plus 4, x, and x minus 6. Anything that doesn't have those, we can rule out. And I see that B could be ruled out. It's got an x minus 4 actually, and x plus 6. C is also incorrect. And then that's between D and E. They've both got the right multiplicity. They both multiply out to x to the 6th power. It's an even function. We have to look at specifically the behavior that we have here. When you have a root that's x squared or x minus something squared, it's gonna have this sort of behavior that looks like a quadratic, which if I draw it out in red here, you can see right here that behaves like an x squared because it touches the axis and it bounces back. Actually, then we have at x minus 6 cubed from answer choice D, it kind of approaches, kind of pulls back, but it eventually passes through, and that looks like the behavior of a cubic function right there. So that right there behaves like x cubed. So D would be the best choice for this one. It tells us that at x equals 0, it kind of behaves like a quadratic. At x equals 6, it kind of behaves like a cubic function. Whereas E has that behavior reversed. Going for D, going for E, yeah. D is the one. What do we got next? Number 60, matrices. I hope you guys are familiar with your matrices a little bit, because this problem says the table below shows the numbers of rows and columns in each of 5 matrices. For distinct values of k, m, and n, which of the following matrix products is not possible? Okay, so for matrix multiplication, we need something that mimics the following. Let's call it m times n matrix multiplied by an n times p matrix. And that will give us a matrix with m rows and p columns. So let me label that a little bit better. This is the number of rows, and this is the number of columns. And basically what that means for matrices is that the number of columns in the first one has to equal the number of rows in the second one. Number of columns in the first one has to equal the number of rows in the second matrix. So let's just check some of these products and see, just like eliminate which ones are possible or not. So E times D. Matrix E has n rows and m columns. Actually, let me highlight this in like a distinct color for each one. Something that stands out, orange. Matrix E has m rows, or sorry, m columns. Matrix D has m rows. So this one works. Matrix D has k columns, and matrix C has k rows. So that one works. Matrix C has n columns. Matrix E has n rows. So that is good. Matrix A has n columns. Matrix E has n rows. So that's good. Last one. Matrix A has n columns. Matrix C has k rows. That one does not work, right? N columns multiplied into k rows. We have a mismatch. And that means that the matrix product is not going to be defined for answer choice K. Yeah, 66 got it. Okay. Let me reshare the screen and see if you guys are able to see this better. Yeah, ACT is weird. They like to start A through E and then F through K. Before I move on for the AMC math problems, I want to point out that I have this page where you can access all my social medias at explore.danstestprep.com. If you want to see more question solving like this, I have a TikTok account. And if you want to get notified about like group sessions or just join my mailing list, there's another one called join.danstestprep.com. But that's up to you guys if you want. You can also just keep coming to Tutor Tuesday, and feel free to submit your questions in a chat as well. Let me move on to our AMC math now. We'll put, okay, immediately sees 13 squared, that's good. Yeah, let me start rewriting this in a way that's more manageable. What is the value of 2,112 minus 2021 squared over 169? We know that 169 is just 13 squared. And this thing right here, 2,112 minus 2021, if we do a little bit of mathematics here, equals 91. Recording of this one. Yeah, so we get 91 squared over 13 squared. We can simplify that and actually just move everything inside like a set of parentheses, 91 over 13 squared. And 91 over 13 it's divisible. It's actually going to be equal to 7 squared, which is 49. And that's exactly answer choice C here. Yeah, 66 got it. Let's move on to our next question. How many integer values of x satisfy absolute value of x equal or is less than 3 pi? Interesting. Not many. Let's think. So 3 pi is approximately equal to 3 times 3.14, right? And 3 times 3.14, that's something like 9.4 or something like that. 9.42. Doesn't matter. We know that x has to be less than 9.4. So x could be equal to 9. Actually, this is absolute value of x. So if we expand out the absolute value as well, we could get something that looks like x has to be between 9.4 and negative 9.4. So the possible values here would just be stuff like negative 9, negative 8, negative 7, 0, 1, so on until we get to 8 and 9. How's that so far? Yeah, include 0. So definitely answer is going to be 19. If you guys want to just count out and verify, we have 9 numbers from negative 1 to negative 9. Another 9 numbers from 1 to 9 plus 0, that middle number of 0. So that's in total 19 values. Let me label that out here. We got 9 values plus 1, and then we've got 9 more. So that's 19. The AMC, I think it's like 2021 AMC 12B, which is where I got this really fun question that says, suppose 2 plus 1 over 1 plus 1 over 2 plus 2 over 3 plus x equals 144 over 53. What is the value of x? Just some basic algebra for you guys. I know you can do it. We'll start by subtracting 2 from both sides, which is equivalent to 106 over 53, right? So, of course, that's going to give us 1 over 1 plus 1 over 2 plus 2 over 3 plus x equals 106 subtracted from 144 is 38. 38 over 53. And then see what you can do here? Let's see in the chat. Do you guys have any ideas of what we can do from this step? Starts with an R. Yeah, reciprocal. So when we take the reciprocal, we get something like 1 plus 1 over 2 plus 2 over 3 plus x. And it's still really long, but we get 53 over 38 here. And again, subtract 1 on both sides. 53 minus 38 is going to be 15. So we get 1 over 2 plus 2 over 3 plus x equals 15 over 38. And we just can keep kind of repeating these same steps, right? Take the reciprocal again, it's going to become 2 plus 2 over 3 plus x equals 38 over 15. And again, subtract 2. I guess it's just like a step-by-step thing. Then we get 2 over 3 plus x equals 8 over 15. Guys, one more step. We're going to speed run this question. Take the reciprocal. 3 plus x over 2 equals 15 over 8. Are you done yet? I know some of you guys are done because you get 3 plus x equals 15 over 4. And then subtract 3 on both sides. And we get x equals 3/4. Just watching? Yeah. 3/4. So that's going to be answer choice A. And the last AMC math problem, which looks real fun, is going to be this one. A log question. I hope you guys have brushed up on your logs because this is going to use like all the log properties that you did and didn't know. So, what have we got here? A right rectangular prism whose surface area and volume are numerically equal has edge lengths log base 2x, log base 3x, and log base 4x. What is x? Let's check the chat. Oh no, logs is right. Yeah, but we can start by setting the surface area equal to the volume, which would make 2 times all the multiples of the sides, length width plus width height plus length height equals to 6 times, or sorry, no, length times width times height. And if I arbitrarily just assign some of these to length, width, and height, like I could call this my length, this my width, and this my height, it doesn't really matter. But we would get 2 times log base 2 of x times log base 2 of, sorry, log base 3 of x plus log base 3 of x times log base 4 of x plus log base 2 of x times log base 4 of x. That's equal to log 2x, log 3x, log 4x. I just substituted those in. Let's see how the chat's doing. This is the only way I kind of figured out how to do this. But then we can simplify things. We can actually divide everything by the volume, which is this thing right here. It simplifies the equation quite a bit. We get rid of a lot of, we have like so many factors here. It's going to look something like 2 times, well, of course, the right side is just going to become 1, right? Equals to 1. That's the simplest part. Inside here, though, if we cancel out the log base 2, log base 3 in the numerator, all we're going to be left with is 1 divided by log base 4 of x. Similarly, for here, we cancel out the 3 and 4, all we're going to be left with is 1 over log base 2 of x. Here, if we cancel out 2 and 4, we're left with 1 over log base 3 of x. All of that equals to 1. Who knows the exponent rule that we're going to use next? Because I definitely had to have a refresher on this one. But we could apply the fact that log base b of a is equal to 1 over log base a of b. Who even remembers this rule? I had to like refresh myself to even solve this question. Yeah, exactly. But if you apply that rule, then we get 2 times log base x of 4. See, everything flips now. Plus log base x of 2 plus log base x of 3 equals 1. And what else have we got? There's one more rule that I know we can use here. Same bases. Exactly. So we can multiply all of these things together. Same bases gives us 2 times log base x of, yes, log base x of 24. 4 times 2 times 3 equals 1. So 2 times log base x of 24 equals 1, or log base x of 24 equals 1 half. Wait, no. What we could do instead is even better. We could apply the I forget what rule it's called. But you could apply that rule that says log base b of a to the n is the same thing as n log b base b of a. So we can, it's the one that says you can move the exponent down in front and make it a multiplier. Apply this rule. Right, so if we just reverse that, we just get log base x of 24 squared equals 1. Or x equals 24 squared, which is equal to 576. Yeah, the rule. The rule. He's got it. 576. That was wonderful. I saw someone put a question up in the chat. Maybe I can solve it. Let's take a look. AMC is kind of fun sometimes, unless it gets like extremely hard. Point x, y, and z lie on a number line at -2, 0, and x3 respectively. Interesting. My first intuition is just to sketch this number line and say maybe like we've got okay, we got points -2, 0, and x3. Point x weighs twice as much as point y, and point z weighs 3 times as much as point y. The weighted average is located at 4/3. So somewhere like 4/3, and I don't like the look of that x3, so I'm going to rewrite it. Explain how to find the location of point z. Let's see. I'm going to try to write an equation here. Don't know if that'll get us anywhere, but hopefully it does, right? I'm going to assume that y is weighted once. So then, like in an average equation, like normally you have like a plus b plus c over 3 equals the average. But if a and c are weighted like twice as much or 3 times as much as y, I'm going to assign multipliers to those. So what I would do here is, let me start by writing the average equation. Point x plus y plus z over 3 is equal to 4/3. But of course, we need some multipliers on those. If y is weighted with an average of, it's just got a multiplier of 1, x is weighing twice as much as point y, and z is weighing 3 times as much as point y. So we're going to count that 2 times and 3 times. If I then plug in some numbers into that, remember we've got numbers for x and y, we'd get 2 times -2 plus 0 plus 3x3 over 3 is equal to 4/3. So I'm going to multiply by 3 right away. So -4 plus 3x3 is equal to 4, or 3x3 is equal to 8. So x3 should be equal to 8/3. Hopefully that was correct. I don't have the answer key for this one, but I would assume that that process works. Any feedback from the question submitter? These ratios. I don't think I did, but I just I found weighted multipliers to x and z. So like if we assume that y is weighted a certain amount, maybe just a multiplier of 1, then we can multiply the values of x and z by 2 and 3 times respectively. Yeah, I guess that just means count it twice or count it 3 times if y is only counted once. That's like the intuitive explanation of what I thought in my head. Any other questions you guys want to submit? Should we cover some reading questions, like SAT reading? Good at reading? Okay, math problem. Let's maybe do like one math and one reading. Calculus? Okay, let's do it. Let me end the official session here and we'll go do some little fun questions together.